everyone. My name is Anjali Sardana. I'm assistant professor in Department of CSC AIML in ABES Engineering College. My topic for today's discussion is data visualization using Matplotlib. The agenda of discussion will be what is data visualization? Why do we need data visualization? And what are the different types of plots that can be drawn using library of data visualization? I'll be talking about line chart, bar chart, histograms, scatter plot, and pie charts. What is data visualization? Data visualization is nothing but the representation of data in pictorial or graphical formats, and they make easy for interpretation and for analytics. And it basically grasps difficult concepts and identify new pattern and ease. It has been observed that it is always easy to analyze the data in form of pictures rather than in form of tables or in form of numbers. If I take the example to understand the need of data visualization, say I have four data sets here, data set 1, 2, 3, and 4, having two columns, X and Y. X is representing some values and Y is also representing the respective value to the value represented in X. So can we make any predictions here, or can we do any analysis here using this just by seeing this data set? Can we find any insights? Can we make any analytics using this data set or just by viewing this data set in tabular format? I think it is very, very difficult. And if I represent the same data set, same four data set using these plots, it is easy to get the insights of the relation between the value of X and the value of Y. So it is always better to have data in form of pictures rather than in form of data in the form of tables. So we have different data visualization libraries: Matplotlib, ggplot, Seaborn, Plotly, Geoplotlib, and all of them are being provided by the Python. I'll be talking about Matplotlib library and will be using the same library for plotting different type of plots. To use Matplotlib library, first we need to install the Matplotlib library, and it can be installed using the command pip install matplotlib. I just have to go to the command prompt and have to type in pip install matplotlib, and the library will be installed. And now to use this library, I have to go to the Jupyter Notebook, or you can use Google Colab for the same. And we can use different platform for performing these operations. I'll be using Jupyter Notebook. First, we have to import the library using this command: import matplotlib.pyplot as plt, where matplotlib is the library name, pyplot is the object name which belongs to the library matplotlib, and plt is the alias that we will be using. After this import statement, we can use matplotlib functions and object by calling them up with plt. Okay, so we can have different types of plots. We'll be talking about these 5 plots in the discussion. First is line plot, then I'll be talking about bar plot, then pie plot, scatter plot, and histograms. We can have many other plots like queer plot, violin plot, a box plot. There are numerous type of plots being provided by your Matplotlib library. But today, in today's discussion, we'll be talking about these 5 plots. Now, what is line plot? It is also called the line graph or line chart, and it is used to display data points connected by straight lines. It shows trends over continuous interval. Continuous interval here means we are talking about the data that is present in form of numbers. We are not talking about any categories here. Here, x-axis represents any independent variable. Usually, it is any continuous quantity, and y-axis represents the dependent variable. And it is used for visualizing various types of data, sorry, such as stock prices, temperature, trends, sale figures, and many more. Now, coming to its practical implementation, I've written code for the ease. I just need to import the libraries first. Import NumPy as NP, which is the basic library that is being used for data handling. Data can be in form of arrays. If you want to handle the data that are present in form of arrays, I need to have NumPy library installed. So I'll be importing the NumPy library first as import NumPy as NP. Then I'll be importing the Matplotlib library using the command that we just discussed, import matplotlib pyplot as plt. Percentage matplotlib inline basically is used so that all the charts has is represented in the script itself. Okay, now let me clear the output once. If I run this code, this library has been imported now. Now I'll be defining the data set. I have not taken any data set from outside or in form of any Excel sheet. I've just created smaller data set for your easy understanding. So I'll be defining the data set as np.arange 0 to 10. The dataset will be creating using this method. Arange function is used to create the list of numbers. Here, list of number between 0 to 10 will be generated with the step value of 1. And y is the basically the dependent variable which is depending on the independent variable x, and the relation is shown like this. If I want to see the value of x here, you can see we have numbers 0, 1, 2, 3, 4 up to 9. And if I keep interval as 2, the number will change like this. If I change the value of step value as 2, the number interval has changed to this. So I'm keeping step value as 1 only and will be using this data for further use. And if I want to see the values of y, you can see if I put value of x here, these values are used to generate the value of y. Okay, here x is the independent variable and y is the dependent variable which is depending on x only. Now I'll be plotting the data points. To plot the data points, I need to have matplotlib. And as shown here, for while importing matplotlib library, I have used alias plt. So I'll be writing here as plt dot plot. Plot is the function used to represent the line plot, and I've just written here the x values and the y values. And if I want to see the plot, I'll be writing plt dot show. You can see here we have uh, uh, we can see a line plot, simple line plot here, where x is representing the values from 0 to 10 interval. That means 0 say like a 9 the values will be there in x, and y will be having these values. And this is the relationship between x and y using represented by a line plot. And if we want to customize the line plot, that we can also do. Customizing here means we basically want to clearly indicate the different x's, what is the title of the graph, and I want to maybe change the line style, the marker style. That can also be done using the code in Python. Here I have kept the same data points x and y. Figure plt.figure fig size 10.5 basically is used to change the figure size. You can change the dimensions of the figure. If you want to have a smaller figure, you can change the dimensions here. And if we want to plot the data points, I'll be using the same method, same function, plot. Plt is alias here, plt.plot, just like this that we have used here. And x and y I'll be passing. Now I'm explicitly telling the line width as well. This is optional part. If you want to customize your line chart, you can use it. Otherwise, you don't have to use it. Line width is used here as a parameter. I have mentioned the line width as 2. Then line style, I want a simple line. If I want a dotted line, I'll be writing double hash, double this symbol. Color is green here. Alpha is used to represent the transparency. One means there is no transparency, solid line will be represented. Marker is used to represent the type of marker that you want to have in your line graph. I can write the demo using plt.title. Plt is the alias, title is the title of this line, this plot. And if I want to have some uh, notations at x-axis and y-axis, that also I can do. I'll be writing plt.x label, x values, plt.y label, y values. And legend is used to describe, having a small description of the line that is being used, that is being represented in the chart. So I'll be writing plt.legend line 1, location will be best, or you can keep the location as per your choice. It can be upper right, upper left, or lower right, or lower left. Then shadow I've kept as true, font size as large, and if I want to have grid in my lines, I can have that as well. If I show how my line chart would look like, you can see here. This is the legend, which is representing the kind of name of the line, and I have kept title as demo. I have kept X label as this X values, kept as Y labels as Y values that you can always change. And grid has been shown here because I've used plt.grid is equal to is true. Line style I've chosen as dotted line, and if I want to have solid line, it is default line as well. If I want to explicitly mention it, that also you can do. I'll be writing as this is a solid line. Marker I've used as plus. If I want to change the line of the color, that also I can do. See here, the color has been changed to red. Okay. Now coming to bar plots. If I come to bar plot, it is also a data visualization method that uses rectangular bars to represent the data values, and each bar height is proportional to the value it represents. And visualizing data like sales by product, population by region can be done using the bar plots. Now, if I see how bar plot look like and how do we create the bar plot. Here we have taken the data in form of dictionary where the key values are the name of fruits and the number is representing the values here. So names is equal to list because data is in form of dictionary and we want to fetch different values here, like key values as a different list and the values as a different list. So I'll be converting the keys here in the list form using this method. I'll be writing list data dot keys. Data is the name of the data that we have. Dot keys. Keys here are apple, mango, lemon, and orange. Here we'll be having different list of names only, and values can be fetched using this command. Values will be 20, 15, 30, and 10 respectively. Then figure size you can change the same as discussed earlier, and I'll be creating the bar plot using this bar method. Earlier for line plot we have used plot method, this plot method, and for the bar method it will be changed to bar. Alias name dot bar, then I'll be passing the x-axis and y-axis. X-axis I want here as names of fruits and y-axis I want the values of fruit. And I'll be writing plot plt dot show. You can see here bar graph has been shown where we have different categories rather than numbers. This is how it is different from the line plot. We can have categorical data on one axis and the respective values on the another axis. So we have categorical data here on x-axis and numbers on y-axis. Again, we can customize the bar graph. We can assign title, we can assign x label, y label, we can change color of bar graph. That we can do using simple commands. You can see here, now I have changed the title to bar graph demo. I have changed x-axis as to quantity and x-axis to fruit and y-axis to quantity. And this has been reflected here. Okay, this was about bar graph. Now coming to your next plot, which is a scatter plot. Scatter plot is a visualization tool that uses points or markers to represent individual data points in two-dimensional space. Each point on scatter plot corresponds to unique combination of values from two variables, one plotted on x and one on y. Basically, it takes kind of intersection of these two values and it shows the correlation between two variables, and it is useful for visualizing relationship between two continuous variables like height and weight, temperature and sales. Like your line plot, it also work on the continuous interval or continuous values. Categorical values are not suitable for these type of plots. You will not be possible to plot categorical values using these plots. Okay. Now coming to the hands-on part. If I want to create a scatter plot, again, I have taken data points, the different variables a, b, and x. A are having some value, b is having some values, and x is also having some values. I'll be writing plt.scatter a comma b, plt.scatter a comma x, and I'll be showing it. You can see different points has been generated. Here we are having two different color points because I have taken two type of relationship to represent the plot. Okay, I can customize, I can even mention what type of relationship blue dot are representing and what type of relationship orange dots are representing. I can customize these things as well. Okay, to customize them, I have used these methods. plt.scatter. Earlier for box plot, we have used box. For line plot, we have used plot. Here for to print the scatter plot, I'll be using scatter. Okay, then x-axis, y-axis, then color is green, size of the marker is 100, edge color I have kept as y, marker I have kept as o, alpha is 0.5, which is representing the transparency. Similarly, other one is other points are representing relationship between a and x. C is kept as red, size as 500, edge color as B, marker as 4. 4 here is like star-like marker. I'll be showing this to you as well. Alpha I have kept as 0.5. And I have assigned legend values as well, B and X. Location I have kept as best fit. Then I can assign the name using, and I can assign the title to the plot as using title method. I have written title over here. X label using X label method, I have written X axis. Y label using Y label method, I have written Y axis to assign the names. Okay, this is what I've done. Now you can see it is a better representation of this scatter plot. I've just customized or made it visually better using some commands. You can see here I have written 4 for this marker. The 4 value here is representing this notation. Okay. Now coming to histograms, this is representing the legend here. Okay. Now coming to histograms, these are histograms. Again, histogram is a graphical representation of distribution of dataset. It breaks down the range of values into bins or intervals and display the frequency or count of data points that fall into each bin. Histograms are particularly useful for understanding the underlying distribution of continuous or discrete variable, and it helps in visualizing various type of data such as analyzing customer demographics, purchase frequencies, spending habits, etc. So we just the difference here is we can work on a single column in histograms. Let me show you. I'm creating the histogram. I've created a list of numbers and I want to find out the frequency of each number here. So I don't have to give both the x's, both the values of x axis and y axis. I can simply work on a single column. So I'll be creating the histogram and that can be done using hist method. Okay. I have just passed the column name, which is number here, and I have given the range of bins here. I'll be using plt.show. You can see here I've given the range of bin. I can change the bin and you'll see the change in result here. If I change the values of bin, uh, the bin size has changed to interval 20. Okay. You just have given these values that has been represented on x-axis, and it is telling you the frequency count. So it basically says that from in the range 0 to 20 we have 5 numbers. In the range 20 to 40 we have 7 numbers, and we don't have any number in the range 40 to 60. You'll not be able to find any number from 40 to 59. Okay. Now again, I can customize the histograms as well using edge color, color of the histogram, title, X label, Y label, and so on. And I have just shown you how I can change the bin size. This is looking a little better. You can change the histogram color as well. You can apply grids as well. This is up to you how much customization you would want to have. Now next is pie charts. Pie chart is a circular data visualization that displays data as a divided circle, where each slice represents a portion of whole. Pie charts are commonly used to show the distribution of categorical data as a percentage of the whole. Histograms are okay. Now coming to pie chart, you can see here I've created a data set, okay, using label and sizes. So what type of label I want to have in pie charts, I've passed it on the label variable to the label variable, and the size of the chart or size of the partition I have passed on to the sizes. In creating the pie chart, I'll be using pie function. Sizes will be passed. These sizes has been passed here, and label will be passed as a next parameter. Title can be assigned using plt dot title. Let's see how our chart looks like. And if I want to have some percentage values here, like what percent of the chart is being represented by blue or red or green or orange, that also I can do using auto packed method. Shadow, I can assign some shadow to this pie chart as well. Okay, I can change the start angle of the pie chart. You can make many customizations in the different charts. You can see some shadow here. The partition has been assigned the percentage as well. Okay, you have changed the start angle to 90. So how you can see how the chart has been changed now. Okay, so this was about different charts using Matplotlib. You can refer to Matplot user guide for more details. Thank you.